Hello grade 8. Today we will make revision about the two lessons that we studied before, 5-6 inequality in one triangle and 5-7 inequalities in two triangles. Let's start. This is our corollary. The measure of an exterior angle of a triangle is greater than the measure of its remote interior angles. Measure of angle 1 more than measure of angle 3 and more than measure of angle 2. Let's solve this question. List the sides of the given triangle in order from shortest to longest. According to the given angles in the triangle ABC, let's put the angles, the measure of the angles in order from the smallest to the greatest. The smallest angle, angle C, is 36 degree. Then this is the first one, angle C, and the middle one, angle B, 57 degree, and the greatest one, angle A, 87 degree. According to the given angles, we can put the side length in order. Here, the smallest side is opposite to the smallest angle. Then side AB is the first one. After that, side AC, because this is the middle one, opposite to the middle angle 57. And the last one, the largest one, is BC, because opposite to the largest angle, angle A, 87 degree. By the same way, we can put the angles in order according to the given sides. The smallest side is DF is 12, then the opposite angle, angle E, is the smallest one. After that, the middle, here angle D, because opposite to side 13, and the last one, the longest one, is the side ED, is opposite to the angle, angle F, is the largest angle. Then the sides in order, DF, EF, and DE. Write the measurements of triangle in order from least to greatest. Here we have only two given angles and the third one is missing. How to find the third angle? By using the triangle angle theorem, we can find the third angle by adding these two given angles and subtract them from 180. Then measure of angle A equals 34 degree. According to the angles, we can put them in order from the least to the greatest. The least angle is angle A. After that, angle C, 47 degree. The last one, angle B, 99 degree. And we can put the sides in order according to the given angles. The side BC is opposite to the smallest angle, then side BC is the smallest side. After that, side AB is opposite to angle C, is the middle one, and the largest one, side AC, because opposite to the greatest angle, angle B. Let's solve this question. Can a triangle have sides with the given length? We have the given length 8, 7, 9. Can we draw triangle with the given length? Let's check if the given length here represent triangle by adding any two sides and check if their sum bigger than the third or not. 8 plus 7 more than 9, and also 8 plus 9 is more than 7. 9 plus 7 more than 8, then the given length we can use it to draw triangle. Let's see the next one. Here we have the given length 3, 11, and 7. By adding any two sides and check if their sum more than the third or not. 3 plus 11, yes, is more than 7. 7 plus 11 is also more than the third side 3, but 7 plus 3 is their sum more than 11? Not. Then the given length, we will not use it to create triangle. We cannot use the given length to draw triangle. Then we will say no. Given side length like 23 and 17, then we can find the answer immediately by adding them and by subtracting them. Then the third side, the possible length of the third side, we can find their difference and their sum. The side length must be more than their difference and less than their sum. Here, by using the same idea to find the smallest value of x, we will add x plus 17 and must be more than the third side 23, and find their difference will be 6. And to find the largest value of x, we will add this given two sides 17 plus 23, then x less than their sum. Then always the third side is more than their difference and less than their sum. Then the possible value of the third side is greater than their difference 6 meters and less than their sum 40 meters.
Let's solve this question. What inequality relates SK to YU? Here, by looking at this triangle, according to our theorem, there are two sides of the first triangle congruent to two sides of the second triangle. AS congruent to OY and AK congruent to OU. The included angle here 90, but the included angle here 70. Then the opposite side to the included angle SK is bigger than the opposite side to the included angle 70, because 90 bigger than 70. Then the opposite side SK is bigger than the opposite side YU. What inequality relates LN to OQ? Since LN is opposite to the included angle between two congruent sides in the two triangles, the side 7, side 4, side 7, side 4 in the other triangle, the included angle here 125 and the included angle here 78, then the opposite side to 125 is bigger than the opposite side to angle 78. Then LN is bigger than OQ. The converse of the Hinge theorem. Here, if two sides of the two triangles, two sides here in the first congruent to two sides of the second triangle, and the third side not congruent, then the larger included angle is opposite to the longer side. Let's compare the given measures. Here, this AC and DF. Since AC is third side of the triangle that has two sides 5, 9, congruent to two sides of the second triangle 5, 9, the included angle here 80, the included angle here 75, then the side AC that opposite to the larger angle 80 is bigger than the side DF that opposite to the angle 75. And also here, by comparing the angles and the given, here we have the third side, the two sides that not congruent, LN, and the other side OQ. This is 23 and the other side 26. Then the opposite angle to 26, angle P, is bigger than the opposite angle to side 23. Then angle M is less than angle P. Here, let's compare the given measures WX and XY. Here also WX is opposite to the smaller angle, angle 51, but side XY is opposite to the larger angle, angle 55. Then WX is less than XY because this opposite to the smaller angle 51. Here, by looking at the next question, this one, Here, this two sides congruent, the side BF congruent to side CD in the other triangle, and the side CF is common, then there are two sides of the first congruent to two sides of the second triangle. The third side 3, this side, is opposite to angle FCD, and the side 3.6 is opposite to the angle BFC, this one. Since the side 3 is smaller than the side 3.6, then the opposite angle to the side 3, the angle FCD, is less than the other angle, angle BFC, that opposite to the side 3.6. How to find the range of the possible values of x? Here, by looking at these two triangles, we have two sides congruent in the first triangle, congruent to the two sides of the second triangle. The included angle 67 and the included angle here 5x plus 2. By looking at the third side, this side 6 and the other side is 5. Since this side 6 is bigger than the third side here 5, then the opposite angle 5x plus 2 is bigger than the opposite angle 67. Then by solving this inequality, we will get that 5x more than 65, then x more than 13. And by the way, any angle in the triangle, it must be more than 0 and less than 180. Since we got the first inequality more than 13, then the second inequality must be less than 180. 5x plus 2 less than 180. Then by solving this inequality, then 5x less than 178, then x less than 35.6. Then the range of the two inequalities, the two values of x is in between, is more than 13 and less than 35.6. In the next question, the other two triangles here, the included angle 95 between the two sides 5, 9, and the included angle here 160 between the congruent sides to the first triangle. Since the included angle 95 is less than the included angle 106, then the opposite side 2x minus 4 is less than the opposite side 32. By solving this inequality, we will get to x less than 36, then x less than 18. And as we said, any angle in the triangle more than 0 and less than 180, and we got the first inequality less than 18, then let's write the second inequality more than 0. Then 2x minus 4 more than 0, then 2x more than 4, then x more than 2. Then the range of the possible values of x more than 2 and less than 18. Let's find the range of the possible values. In the two triangles here, we have two sides congruent. This side that made arc here, make dash here, this side is congruent to this one. And the side 50 congruent to this side 50. Then the included angle is 55 and the included angle here is 68. Since 68 more than 55, then the side that opposite to the smaller angle, then 5x plus 2 is less than the other side 47 that opposite to the larger angle. Then 5x less than 45, then x less than 9. The other one, 6x plus 15, this angle is more than the other angle 65. Why? Because this angle opposite to the side 11, and the side 11 is bigger than the side 9, the third side. Then 6x plus 15 more than 65, this angle. then 6x more than 50, then x more than 8.3. In the first question, we didn't write the other inequality. Let's write it. Here we said this is less than 47. We got the first inequality, x less than 9. Then let's write the second inequality, more than 0. Yes, more than 0. Then our inequality, 5x plus 2 more than 0. Then 5x more than negative 2. Then x more than negative 0.4. Then our range, the possible range of our variable x is more than negative 0.4 and less than 9. The other one here, this one, we got the first inequality more than. Let's use the second inequality, less than, yes, less than 180. Then 6x plus 15 less than 180. Then 6x less than 165. Then x less than 27.5. Then the possible values of x are x more than 8.3 and less than 27.5. Thank you for listening and have a nice day.